You're in the front now. I can hear you. Hey, let's begin. Lesson 1, exponents. You know what exponents are? All they are is a shortcut. Psst. They are a short way to write repeated multiplication. So, for example, instead of writing 2 times 2 times 2, what's a shorter way to write that? 2 to the third power. Don't you dare say 2, 3. Right? Gotcha. Oh, and as you've already pointed out in the question that you asked me earlier, kiddo, they can also be used with variables. So the repeated multiplication of a times a can be written in exponential form as a cubed. How do we show that it's an exponent? We write it as a, does anybody know the fancy word for something that's up there? The last syllable is script. Subscript is down below, superscript. Superscripts and subscripts. So in chemistry, we use subscripts in chemical formulas to show you how many of each are required. Superscript is an exponent here in math. Power. A power is a base and an exponent. Exponent. Let's try that again, Mr. Duke. Exponent. And let's see if I can move that up just a tiny bit. Yeah, to there. It consists of a blank and an blank. It's a repeat of what we just said. What does a power consist of? A power consists of a power. Yes, no, more specific. It consists of what two things? Yeah, a base and an. And we've given you a lovely picture there. A is the base. That's fairly easy to remember because when you talk about a basement, it's the lower thing, the base, the lower thing. And I think most of you over the years have learned what an exponent is. When you have a base with an exponent, we call that a power. Next page. Example 1 says, state the base and the exponent in each of the following powers. Okay. How about we go B and E, B and E, B and E. What's the base in this first one? 4. What's the exponent? What's the power? 4 to the 7th power. What's the base in this second one? What's the exponent? What's the base in the third one? A. What's the exponent? X. A little note, a number that multiplies a variable is called a, we've already done this term before, but let's write it again, coefficient. So in the expression 8x cubed, the coefficient is 8. It says state the coefficients of the following. All right. What's the coefficient of part A? 9? Or are you a German saying no? I'll never get tired of that. Yeah, 9. What's the coefficient of B? 7. Coefficient of C? -5. Coefficient of D? Careful. -1. Tyler, you've had me now for about 2 months, just about. Well, actually, almost 3 months. Will I ever put the 1 in front there, even though it's there? I'm lazy. It's invisible. Once in a blue moon, if I really think it's going to keep me from making a mistake, I'll put it there. Otherwise, I know it's there. Important note, if you see 8x cubed written as repeated multiplication, because the exponent is only on the x, Amy, it would be 8xxx, not 888 times xxx. Oh, however, if I wanted to write 888 times xxx, I would use brackets and I would put the exponent on the outside around the brackets. That's our way of saying the exponent goes on to everything inside the brackets. It would be 8x times 8x times 8x. So example 3 says, write the following as repeated multiplication. write these the long way. 4a squared b cubed. What is that really? 4 times a. You know what? Because my timeses look like x's, and I'm going to be using some x's probably, what's another way to write times? Another symbol that we use. This is why, one of the reasons we bring in the dot. So I'm going to go a dot b dot b dot b. B, it says write that as repeated multiplication. Hey, wait a minute. Isn't that already in repeated multiplication? They didn't use dots, they just put them, but there's no exponents. Already is. Nope, I wouldn't take marks off. -3 times a times b times c. I'm saying, though, I don't think I'd change it. What about question C? 3 times what? Yeah, you could go times AB times AB times AB times AB, or you could have gone this way. You could have said it's 3 times A times A times A times A times B times B times B times B. Right? What we're really saying is there's a single 3, there's 4 A's, there's 4 B's. Which one's correct, Mr. Dewick? Yes. No, I mean, nice. Which one's right? They both are. Yes. You know what? There's no official rule for repeated multiplication. What we're really saying is, look, if you expand this, make sure you got 4 A's and 4 B's somewhere. I would prefer the bottom one because I like stuff alphabetically, but that's just me as a nerd who likes things organized. That's not me as a math teacher saying, thus shall it be, to get the mark. D. How is D different from C? Yeah, so going to your question, Darian, I have no problem if you go 3AB dot 3AB dot 3AB dot 3AB. I kind of see that as 4 3's, 4 A's, 4 B's. That B looks weird. Which one's right? You know what? They're both more useful in certain different areas. This brings us to the exponent laws. Now, once again, we have the magic word simplify. In the unit that we just finished, simplify for a radical meant pull out any perfect squares or perfect cubes or perfect fourths, depending what the root was. 2 units ago, polynomials, simplify usually meant FOIL it out and gather like terms. This is why simplify is a tricky word. It has a lot of meanings. What it's supposed to really mean, Alex, whenever you see simplify, is write it as tidy as possible. But kids kind of forget. Here, simplify means write the answer as a nice tidy power, as 1 power, please, without brackets and without a bunch of extra exponents kicking around. So, along the law of multiplication, when we multiply powers with the same base, hey, what do you do when you have a to the 5th times a to the 9th? Add what? Why? I bet you last year, or whenever you first learned this, whether it's grade 7 or grade 8 or grade 9 math, your teacher said something like this. Well, if I go x cubed times x squared, that's really, or a cubed times a squared, that's a, and then they said, how many a's are there grand total? So they said, oh, this is really a to the 5th, and then they said, okay, smarty pants, what if we got rid of that? Can you find an easy way to get there? And Garrett says, oh yeah, if I take that 3 and that 2 and do what? Add them. I mean, I could probably come up with a fancier proof, but Simi, there's a simple one, right? So, speaking of, Garrett, my friend, what's the answer to 1? No. That's battleship. Y to the 5th. Boy, you're lucky I wasn't your Math 9 teacher. I would have beaten you this out of you last year. What's the answer to number 2? X to the 11th. By the way, do you see also, Garrett, by saying that it really emphasizes what's on the bottom and what the power is? Otherwise, I have to try and visualize what you mean by Y5, and I have to assume you don't mean that, although I've seen that show up sometimes. Yes? So we'll be fussy and nerdy from now on. Will you take marks off? No, but I'll make fun of you every time. Ooh. What about the third one there? Did somebody actually say A2 back there? I hope not. They would have said A squared or A to the 2. Okay. Tell you what, Bonson Park, 3 o'clock. If I'm not there, start without me. Okay. What's the opposite of multiplying? What's the dividing. So if you had to make a guess, if when you multiply you add the exponents, you divide, you subtract. There is a nice symmetry to that. Dividing and multiplying are opposites, adding and subtracting are opposites. And Simi, I could do a similar proof by writing out 5a's divided by 3a's, a over a, and you would see, oh, there's only 2 a's left. Oh, subtract. So what's x to the 5th divided by x cubed? X to the 2 or x squared? Mr. Duke, how come they have squared and cubed, but they don't go past that? Squared and cubed show up so often in physics, and we just got, they have special names. There is no fancy name for x to the 4th. It's called a quartic, but we don't use that term. X to the 7th divided by x to the 4th. X cubed. X to the 4th divided by x to the negative 2. Careful. It's not x squared. Angela, why is it x to the 6th? Because this is going to be x to the 4 minus negative 2, because you subtract the exponents. And Darian, what's a minus minus the same as? And Darian, I'm so glad you made that sloppy mistake, because you did say x squared. I think it was you, yes? Someone over there did. Because it brings us to one of my beefs with exponents, and that is negative exponents. You know when we're going to make dumb mistakes in this unit? When the exponents are what? Negatives. So one of my strategies as we move through this is going to be to say to you, I am never going to do math with negative exponents if I can help it. I'm going to give you a way to change a negative exponent into a positive, and then I'm going to say, let's do the math with positives. And we'll be able to, about 99% of the time, Amy, avoid this question here. Next page. The power of a power law. When raising a power to an exponent, what I mean is something like this. Here's a power to another power. Who remembers this one? Yep. So it would be x to the what? So what would you do with the two numbers mathematically? Prove it. It's not that hard a proof. I would say this really means x squared, x squared, x squared, x squared, x squared, 5x squareds, yes? And then I would say, oh, now I'm multiplying. What do I do with those exponents? Add them. And when you go 2 plus 2 plus 2 plus 2 plus 2, what do you get? And then I would say to you, Garrett, Mr. Smarty Pants, okay, what if that wasn't there? How can you think? Oh, and you would say, oh, if you give me a 2 and a 5, I times them. Now, Sam, the biggest mistake, kids get this rule mixed up with this rule. Don't do that! I haven't got a good way to help you remember. I can yell, but I haven't got a good way to help you remember except lots of practice and don't do that, don't do that, don't do that. Please don't do that. Pardon me? What about the brackets? Like this here, you mean? If you see brackets, like in these examples, or so that tells you that everything inside the brackets is going to be raised to the exponent outside. So, hey, what do you think number 1 is going to work out to be? X to the what? 6th. The second one, x to the 8th or x to the 15th? 15. The third one, a to the 4th. Oh, it's not x, it's a, Mr. Duick. Is that what you're saying, Sam? Somebody said that. Garrett asked a great question. Hey, Mr. Duick, what if you have this? Times. What's the exponent right on the z? It's invisible. Times. So it would be x to the 10th, y to the 15th, z to the 5th. Is that what you're asking me? Yeah. Which kind of makes sense. I do like the exponent rules in that actually if you work your brain around the first two, multiplication, division, everything kind of falls out of that. Oh, what if we have the power of a quotient, a fraction? If you have a fraction in brackets with the exponent outside the fraction, the exponent goes on to the top and it goes on to the bottom, which also kind of makes sense. In other words, x over 2 all squared, which is how I would read that, is x squared over 2 squared. But 2 squared I can simplify. X squared over 4. What do you think here? A to the 6th, I totally agree, Ty. What else? B to the 9th. Yep. This is kind of fun, Mr. Duick. Yeah, turn the page. It can be if you do the homework. In all honesty, Garrett, when I teach math, maybe I've used this phrase already. We're all good, Naomi? Update your status. I'm learning exponents. Put the phone away. I used to tell kids, Garrett, you know what? Most of math is useless that we teach you. It's weightlifting for your mind. Do you work out? Seriously? Because you're an athlete, yes? Okay. I'm willing to bet at least once you've done a bench press. There is no job on the planet that you can get where you bench press. So why do you work out? In fact, in lacrosse, you don't bench press at any time during the game. Why do you work out? The muscles that you build during the bench press are some of the many muscles you use in lacrosse, yes? There is no job aside from math teacher or mathematician where you're going to need to factor a trinomial. None. So why do we do it? We're building mental muscle. This is the most abstract stuff you'll learn in school. And one of the reasons it's tough is the same reason it's tough to bench press 300 pounds. Some of you need to develop some more mental muscle, and that's my job. I'm your, Arnold Schwarzenegger coach yelling at you and pushing you. But that's really what this is for. So you ever ask me, when are we going to use this stuff? A lot of it, never. So the curriculum's slowly getting better. There is some useful stuff in it that you might actually use. If you take pre-calc 11 and 12, or foundations 11 and 12, you'll do stats, combinatorics, and probability, and those three are useful. Play cards, gambling, I kind of want to know what the odds are. But yeah, a lot of the stuff that we teach you, Kira, you know what? It's weightlifting for your brain. I like it because I don't mind working out. Not everyone does. And you may know people at your age already that really enjoy working out, and you may be looking at them going, oh, how can you enjoy spending an hour getting sweaty and tired like that? I can enjoy spending an hour working my brain through math. It can be fun. See, wasn't that a great little segue back to here? Hey, what's this next one, number 3? Yep. And now I need you all to get your calculators out. If you don't have a calculator here, you want to look at somebody nearby. Do I have to reduce? What do you mean by reduce? Oh yes, but there is no way to simplify that, right? And I don't think there's been any that I've been able to simplify along the way here. It's a to the 6th, b to the 9th. Sesame Street is brought to you today by the letter A, the number 6, and the letter B. Mr. Dewick, leave my self-esteem alone. Sorry. Get calculators out? Okay, put them down for 1 second. I'm going to ask you a question that I want you to do in your head. Read this number to me. What's negative 2 times negative 2? So that means if I go negative 2 squared on my calculator, I should get 4. Try it. Don't type negative 2 times negative 2. I want you to type negative 2, hit your squared button.
Negative 4.
Sorry, what? You don't get 4? What's going on? You need to know how your calculators work. This is very important because this is one of the common mistakes that occurs when kids are trying to evaluate this stuff. Your calculator, when it sees this, it does BEDMAS. What is BEDMAS? What does the B stand for? Brackets. Do you see any brackets in there? So it doesn't do that. What does the E stand for? Here's what your calculator does. Oh, you want me to go 2 squared. It does that. What is 2 squared? 4. And then it says, and I guess you want me to multiply that answer by negative 1. Which is correct. It's doing it right, by the way. If you want to put a negative number to an exponent on your calculator, you have to put it in brackets. If you want to get negative 2 squared and get that positive 4 as an answer, you have to type that. Try it. Bracket, negative 2, close bracket with the squared outside. Okay? You better believe on the provincial, if they give you a question like this, one of the multiple choice answers will be the negative answer that's the wrong one. In fact, they'll probably put it as A, the first one to pick from. Absolutely. Okay? So, going back to our notes, when you have a negative base with no brackets, then your answer will always be negative. Written that there. That says 3 squared, then make it negative. It means 3 times 3, make it negative. The second one, negative 5 cubed, that means 5 times 5 times 5 with a negative in front, please. Both of these will work out to a negative answer. Now this second one, because there's 3 of them, even if you type it in wrong, you'll still be okay. If I have an integral, a negative base with brackets around it, this means negative 3 times negative 3, positive 9. In fact, you ready? Brianna, when you're done yawning, the exponent, odd number or even number? The 2 there, odd or even? You're going to get a positive answer if the negative is in brackets. Odd or even? You're going to get a negative times a negative times a negative. You're going to get a negative answer when all is said and done. Odd or even? You're going to get a negative times a negative times a negative times a negative times a negative. You know what? You're going to get a negative answer. If you're looking for a shortcut, if you want to try and figure out ahead of time whether your final answer is going to be positive or negative, assuming the negative is in the brackets, even exponent, the negative will cancel. Odd exponent, you'll still have 1 extra negative kicking around. So this would be positive 9. This would be negative 64. This would be negative 32, I think. 2 times 2. 2, 4, 8, 16, 32. Yes. So it says evaluate. 3 to the 4th, no calculator. What's 3 times 3? Times 3? Times 3. That's the dumb way to do it. It can be done. Here's what I see. What's the question? Can you, Sam, read me the question? A, what does it say?
3 to the power 4.
Here's what I see. Is that not still 3 to the 4th because of the addition exponent rule? See, I see 9 times 9, which all of you know, is what? Trying to give you some tricks so on the non-calculator section of the provincial you can deal with bigger numbers. Negative 2 to the 5th, is the negative inside the brackets? No, so it's going to be 2 to the 5th, then make it negative. One hand up, please, the hand that you're not writing with, in a fist. Thumb out. 2, 4, 8, 16. What's 2 to the 5th? 32. What's 2 to the 6th? What comes after 32? 32 and 32 is? 64 and 64 is? 128, 128, 128. You know what? You can probably, in your head, Simi, in a pinch, do all the powers of 2 up to 10. Probably. 128, 256, 512. And you may recognize some of these numbers if you have a computer, because computers are based on powers of 2. It's why lots of memories come in. Oh, it's a 256 megabyte little thumb drive, or a 512 megabyte little thumb drive, or now they're all gigabytes anyways, but back in the day. So this is 32. Make it negative, right? Because there's negative in front. C. Hey, will my final answer be positive or negative? So let's ignore the negative. I don't see 5 to the 4th. I see 5 squared, 5 squared. Do you guys know what 25 times 25 is? Because this one this is one of the few bigger squares that I do have memorized. It's 625. D, negative or positive? Let's put that in before we forget. And it's negative 5 times negative 5 times negative 5. Oh, for Pete's sakes, it's negative, and then there's going to be a 5 cubed, which we did this past unit. 125, right? That was one of our perfect cubes. A few more, we're done. E. What would negative 2 to the 3rd be? This would be 2 times 2 times 2, then make it negative. Negative 8. What would negative 5 to the 1 be? In fact, what's anything to the 1 power? Just itself. There is a rule for that. We're not going to write it down. I think you guys have kind of picked up on that, right? So negative 5. What's a million to the 1 power? What's a trillion to the 1 power? What's x to the 1 power? What's car to the 1 power? Car, if that was a variable. Anything to the 1 is itself. All right. Example 5 says, use exponent laws to simplify and then evaluate. 3 to the 4th times 3 squared is 3 to the what? Or 9 times 9 times 9. Okay, this is a bit big to do in my head, so now we better find out where our exponent button is on our calculator. Okay. Most of you, your exponent button will look like this little hat symbol here. Some of you, your exponent button, if you have a cheaper calculator, might look like this. You need to find that somehow so that you can go 3, press your exponent button, 6, and get 729 as an answer. If you can't find that, now is your chance to ask me. Go hunting for it. B. 4 to the what? That's the simplify, and then it says evaluate, which means give an answer. What is 4 to the 7th? 16,384. C. The negative 2 is in brackets, so negative 2 to the what? To the 7th. Will my final answer be negative or positive? It's going to be negative. Put it in brackets when you type it on your calculator. Bracket, negative 2, close bracket. 2, 4, 8, 16, 32, 64, I think 128, yeah. D, negative 3 to the what? Greg, you're right. I think you're right. Yep. No calculator. What is negative 3 all squared? Positive 9. Ooh. E. 4 to the what? Careful. 4 to the 6th. 4,096? And Mr. Dewick, will they give us stuff like that on the non-calculator section of the provincial? No. You know what they'll give you on the non-calculator section? Variables. Because they're easier to do math with. They're trickier to do algebra with, but they're easier to do math with. So, example 6. What's A? A to the 5th. Nice. What's B? Garrett. Yep. What's C? Careful. C? Move it across. Not down. C. You guys have a C on your sheet, yes? X to the 6, right? 3, 2, and 1. Alex, what's D? Oh, you're so smart. Or if you really want to say it nerdy, x squared. What's E? Now, I'm going to give you a different way to think about this, by the way. When I look at D, I say, how many x's are there on top? No, D. We're looking at D again. 11. How many on the bottom? How many left and where? I think 2 left on top. Okay? Slightly different way to think about the subtraction rule. When I get to E, I see 5 x's on top. I see 1 x on the bottom. I say, how many will be left? 4. Where? On the top. Why are you doing that, Mr. Dewick? When we get to negative exponent, that's the trick I'm going to show you. What's F? Hey, 5 more. Try them yourself. Let's see if we get the same answers. I'll freeze the screen. Try G, H, I, J, and K. Holy smokes, yeah, you can do it. You guys are trying this, right? Right. I got that, I think. That first one doesn't look much like a 3, does it? Let's try that again. For G, I got x cubed a to the 6th, yeah? No, yes. For H, I got x cubed over a cubed. For I got r to the 15th over a to the 25th. For J, I got a to the 8th, x to the 12th. And then for K, I got 2 to the 4th, but I know that 2 to the 4th is 16. A to the 8th. Mr. Dewick, would you take it if we put 2 to the 4th? Yeah, usually my rule of thumb is if I evaluate it and it's less than 10,000 or so, I'll probably write it out. If it's more than 10,000, like big, I'll leave it as an exponent. But certainly if it's less than 100, oh, for Pete's sakes, evaluate it. What's your homework, you ask? Officially, your homework is study for the test. I'm going to give you an assignment, but it's not due until Monday.